Chirality is a property of asymmetry important in several branches of science. The word chirality is derived from the Greek kaɪ-rælɪtiː, hand, a familiar chiral object. An object or a system is chiral if it is distinguishable from its mirror image, that is, it cannot be superposed onto it. Conversely, a mirror image of an achiral object, such as a sphere, cannot be distinguished from the object. A chiral object and its mirror image are called enantiomorphs, or, when referring to molecules, enantiomers. A non-chiral object is called a chiral and can be superposed on its mirror image. If the object is non-chiral and is imagined as being colored blue and its mirror image is imagined as colored yellow, then by a series of rotations and translations the two can be superposed, producing green with none of the original colors remaining. The term was first used by Lord Kelvin in 1893 in the second Robert Boyle lecture at the Oxford University Junior Scientific Club, which was published in 1894. I call any geometrical figure, or group of points, chiral, and say that it has chirality if its image in a plane mirror, ideally realized, cannot be brought to coincide with itself. Human hands are perhaps the most universally recognized example of chirality. The left hand is a non-superimposable mirror image of the right hand, no matter how the two hands are oriented. It is impossible for all the major features of both hands to coincide across all axes. This difference in symmetry becomes obvious if someone attempts to shake the right hand of a person using their left hand, or if a left-handed glove is placed on a right hand. In mathematics, chirality is the property of a figure that is not identical to its mirror image. In mathematics, a figure is chiral if it cannot be mapped to its mirror image by rotations and translations alone. For example, a right shoe is different from a left shoe, and clockwise is different from anti-clockwise. A chiral object and its mirror image are said to be enantiomorphs. The word enantiomorph stems from the Greek nu alpha nu tau iota rho micron sigma, opposite plus mu omicron rho phi eta, form. A non-chiral figure is called a chiral or amphichiral. The helix and Mobius strip are chiral two-dimensional objects in three-dimensional ambient space. The J, L, S and Z-shaped tetraminos of the popular video game Tetris also exhibit chirality, but only in a two-dimensional space. Many other familiar objects exhibit the same chiral symmetry of the human body, such as gloves, glasses, and shoes. A similar notion of chirality is considered in knot theory, as explained below. Some chiral three-dimensional objects, such as the helix, can be assigned a right or left-handedness, according to the right-hand rule. In geometry, a figure is a chiral if and only if its symmetry group contains at least one orientation reversing isometry. In two dimensions, every figure that possesses an axis of symmetry is a chiral, and it can be shown that every bounded achiral figure must have an axis of symmetry. In three dimensions, every figure that possesses a plane of symmetry or a center of symmetry is a chiral. There are, however, achiral figures lacking both plane and center of symmetry. In terms of point groups, all chiral figures lack an improper axis of rotation. This means that they cannot contain a center of inversion or a mirror plane. Only figures with a point group designation of C1, Cn, Dn, T, O, or I can be chiral. Knot theory: a knot is called a chiral if it can be continuously deformed into its mirror image, otherwise it is called chiral. For example, the unknot and the figure 8 knot are a chiral, whereas the trefoil knot is chiral. In physics, chirality may be found in the spin of a particle, which may be used to define a handedness for that particle. A symmetry transformation between the two is called parity. Invariance under parity by a Dirac fermion is called chiral symmetry. Electromagnetic wave propagation as handedness is wave polarization and described in terms of helicity. Polarization of an electromagnetic wave is the property that describes the orientation, i.e., the time-varying direction and amplitude of the electric field vector. For a depiction, see the image to the right. Chemistry. A chiral molecule is a type of molecule that has a non-superposable mirror image. The feature that is most often the cause of chirality in molecules is the presence of an asymmetric carbon atom. The term chiral in general is used to describe an object that is non-superposable on its mirror image. In chemistry, chirality usually refers to molecules. Two mirror images of a chiral molecule are called enantiomers or optical isomers. Pairs of enantiomers are often designated as right, left-handed, or if it has no bias, a chiral. As polarized light passes through a chiral molecule, the plane of polarization, when viewed along the axis toward the source, will be rotated in a clockwise or counterclockwise. A right-handed rotation is dextrorotatory, that to the left is levorotary. The D and L isomers are the same compound but are called enantiometers. A equimolar mixture of the two optical isomers will produce no net rotation of polarized light as it passes through. Left-handed molecules have L prefixed to their names, D is prefixed to right-handed molecules. Molecular chirality is of interest because of its application to stereochemistry in inorganic chemistry, organic chemistry, physical chemistry, biochemistry, and supramolecular chemistry. Biology. In anatomy, chirality is found in the imperfect mirror image symmetry of many kinds of animal bodies. Organisms such as gastropods exhibit chirality in their coiled shells, resulting in an asymmetrical appearance. Over 90% of gastropod species have dextral shells in their coiling, but a small minority of species and genera are virtually always sinistral. A very few species show an equal mixture of dextral and sinistral individuals. In humans, chirality is an attribute of humans defined by their unequal distribution of fine motor skill between the left and right hands. An individual who is more dexterous with the right hand is called right-handed, and one who is more skilled with the left is said to be left-handed. Chirality is also seen in the study of facial asymmetry. In flatfish, the summer flounder or fluke are left-eyed, while halibut are right-eyed.